equations. Up here at the top of our notes, it says that every solution to the equation, and then it gives a derivative equal to Kp, can be written in the form P equals P sub 0, where P sub 0 is the initial value, the starting value, e to the kt power. And K is our growth or decay, depending on whether K is positive or negative. If K is positive, then we have growth. If K is negative, we have decay. And then T just represents time. So on our notes from last week, 79, we had down at the bottom of the page this exact same thing. It's saying that if we integrate this, we're always going to end up with this, where C in the notes today, it's called P sub O, is going to be our constant or our initial value, and then K and T represent our growth or decay and our time. So that same formula that we end up with is a formula that you guys used in pre-cal. So over a year ago, we had these notes in pre-cal, 8-7 notes, and we had all of these formulas that we use for word problems for exponential growth or decay. And some of them required logarithms when we began to solve. But if you look at this one, this is the formula we're using today. So we're back full circle. This one was used when we had something that was compounded continuously. And so those were compound interest problems most of the time in pre-cal. Doesn't have to be money. It could be something else, as we'll find out today. So the first part of what we're going to do today, and this is supposed to have an equal sign in here, so you may want to add that in. It's supposed to say that a cup of coffee at a temperature at 180 degrees Fahrenheit is placed on the table at a room at 68 degrees Fahrenheit. The differential equation for its temperature at time t is dy dt equals negative 0.11, and then parentheses y minus 68. And then it also tells us the initial condition that when t, or x in this case t, is 0, that we get 180. So once we have taken the integral of both sides of this to get our equation, then we can plug this in to find our constant. So that's what we want to do. So the first thing I'm going to do here is multiply both sides by dt. So just move the dt over here. So I would have dy equals negative 0.11 y minus 68 dt. All right, so then we want to divide by the y minus 68 to separate our variables like we did last week. And so I have 1 over y minus 68 dy equals negative 0.11 dt. All right, so this is exactly what we did last week. Now we want to integrate that so that we can come up with our equation. So I know from last week that the integral of 1 over this value is going to be a natural log of y minus 68. And then that's going to equal negative 0.11 t plus some constant. Now, when they're asking us to write the equation, they're asking us for the general form, the general solution. And so we're going to go ahead and rearrange this so that we can get y by itself. So e to this power, e to the negative 0.11 t plus c power will equal y minus 68. And remember that this is e to the negative 0.11 t times e to the c, because the addition was multiplication before. And we talked about this, that it's just an unknown constant, so we can place it at the front. It's just a constant times e to the negative 0.11 t power equals y minus 68. Oh, scoot that up a little bit. All right, so we can, well, I guess we could go ahead and add the 68. We have c e to the negative 0.11 t plus 68 equals y. So now they gave us this initial condition. When t is 0, then y is 180. So c e to the negative 0.11 times 0 power plus 68 equals 180. Well, e to the 0 power here is just 1. So we just have c plus 68 equals 180. So if I subtract 68, c equals 112. All right, so the equation that I get when I plug in 112, let's see, we'll use this one right here, this form. So I have y equals 112 e to the negative 0.11 t power plus 68. So that is exactly what we did last week. All right, so now we're going to get to our questions. And these questions are what we did in pre-cal last year. So part A says, after 10 minutes, what's the temperature of the coffee? So we're just going to put 10 in for T. Y equals 112 e to the negative 0.11 times 10 power plus 68. And then we're just going to solve for y. So we'll type that into the calculator here. 112 e to the negative 0.11 times 10 power plus 68. So here it is. Well, kind of bright on that. All right, so there we go, 105.282. Y equals 105.282. And Y in this problem is representing degrees Fahrenheit. So coffee's dropped in temperature a little bit in those 10 minutes. All right. For part B, it says approximately how long does it take the temperature of the coffee to drop to 75 degrees Fahrenheit? Well, again, Y is our degrees or our Fahrenheit value. So we're going to put that at the front of our equation, equal to 112 e to the negative 0.11 t plus 68. All right, so in this problem, since t is in the exponents, we're going to need to use logarithms to solve. And that's the part last year we learned in pre-cal, that as long as our variable was down here, as a replacing a constant in the equation, then we didn't have to use our logarithms. But anytime that variable is up in the exponent, you're going to probably need logarithms to solve that. So first thing we're going to do is still just subtract the 68. So we have 7 equals 112 e to the negative 0.11 t. Sorry about my dogs. All right, then we're going to divide by 112, because remember, our goal is to try to get that t by itself as much as we can. Oh, that's a 112, not 122. Okay, so now we've done everything we can to isolate this term right here, but I'm stuck. So this is where I need to take the log of both sides. I'm going to take the natural log, since we have base e here, the natural log of 7 over 112 equals the natural log of e to the negative 0.11 t power. And I don't know if you guys remember, so I'm going over all the steps again, but whenever you're solving this type of equation, the exponent moves to the front. So we have ln of 7 over 112 equals negative 0.11 t ln of e. All right, the ln of e is just 1, so that is gone. So we're going to divide both sides by negative 0.11. And t equals this number. So let's type it in the calculator here. We have ln of 7 over 112 divided by negative 0.11. So here it is in the calculator. So we get 25.205. And this is our time, and time in this problem was in minutes. So in approximately 25 minutes, it's cooled down to 75 degrees. All right. So in our second example here, we have a bacteria problem. So we did some bacteria problems last year too, but this one says at any time, t greater than or equal to 0 in days, because we can have negative time, the rate of growth of a bacteria population is given by y prime, or the derivative of y, equals ky, where k is the constant and y is the number of bacteria present. The initial population, so the beginning time, or sorry, the beginning number of bacteria is going to be 1,000. And it says the population triples during the first 5 days. So that's going to come in handy after we get our equation written. So part A says write the expression for y at any time t greater than or equal to 0. That means they want us to solve the differential equation. And so our differential equation this time is y prime equals ky. And it doesn't have much in there. It doesn't give us a lot of information. But remember that this y prime is dy over dx, or in this case, it's time. So dt equals ky. So this is just another way of saying that. Now we know that we need to integrate, but before we do that, we got to separate the variables. So we're going to multiply by dt. So those are gone. And I'm going to divide by y. So I have 1 over y dy equals k dt. And then I need to integrate. So the integral of 1 over y would be ln of y. Integral of k would be kt plus c. And again, they want that general form, general solution. And so we're going to go ahead and solve for y. So e to the kt plus c power will equal y. Remember, that's e to the kt times e to the c. And e to the c is just our constant. So c, e to the kt power equals y. Now, if you know the formula, if you remember what we started out with in our notes, or from our notes on separation of variables last week, we know that anytime we have this form, it always ends up in this form. And since this one was just all letters, there wasn't any specifics given, here it is again, this goes to this form, then we could have just jumped over here to the conclusion at the very beginning that y equals y sub o, or p sub o in our paper, e to the kt power. So this is the same thing as this that we got. You can derive it yourself, but that's one benefit of knowing that formula, because you could save yourself all this time. But it's okay, because if you don't remember it, you can always solve, just like we did. Okay, so now we're going to go ahead and use our information to finish out our equation so we can solve for C, our constant here in the front. So it tells us that when the population is 1,000 and it triples during the first 5 days. So let's see, we start off with 1,000, that's our initial amount. Our time is 5 days, so we're going to have 5 for t. And if it's tripling, this is the part I was thinking about, if it's tripling, then our outcome amount is going to be 3,000. All right, so we have our equation that we need to solve here. So we're going to, we see that our variable is in the exponent, so we're going to try to solve for that variable. So we're going to divide by 1,000. So we have e to the 5k power equals 3. And so in order to solve for k, we're going to need to take the log, or the natural log, of both sides. and bring the exponent to the front. So we have 5k ln of e equals ln of 3. Now ln of e is just 1, so divide by 5. So k is ln of 3 over 5. All right, so our equation is going to be y equals the initial amount, which was 1,000, e to the kt power, and k in this problem is ln of 3 over 5 times t. So this is our equation. Well, that's a pretty terrible looking exponent, but and we could simplify that with a little bit of pre-cal, but there's no harm in leaving it just like it is. So that's going to be our expression for y at any time where t is greater than or equal to 0. So this is our answer to part A. Part B, it says, by what factor will the population have increased in the first 10 days? So 10 would be a time, so they just want us to put 10 in for our time. So y equals 1,000 e to the ln of 3 over 5 times 10 power, or 1,000 e to the 10 divided by 5 would be 2. So 2 ln of 3 power. Okay, so we're going to type that in the calculator. We have 1,000 e raised to the 2 ln of 3 power. Here it is. We get 9,000. So y equals 9,000. So it says, by what factor will the population have increased? So if it goes from 1,000 to 9,000, initially it's 1,000, now it's 9,000, then it's increasing by a factor of 9. Increasing by a factor of 9. All right, then part C. It says, at what time in days will the population have increased by a factor of 6? Well, if it increases by a factor of 6, then our outcome amount is 6,000, and that's going to be our y value. So 6,000 equals 1,000 e to the ln of 3 over 5 times t power. So t is in our exponent. We're going to need to try to solve, and it's going to involve some logarithms. So our 1,000 will divide out. We have 6 equals e to the ln 3 over 5 times t power. So everything is still up. I mean, this is all exponent, so we can't do anything else except take the log of both sides. So ln of 6 equals, and I'm going to bring the exponent down. So t ln of 3 over 5 ln of e. So this is my exponent I brought to the front, and then ln of e. So ln of e is 1. So we're just going to divide both sides by ln of 3 over 5. Divide by ln of 3 over 5. So t will equal this. So we have ln of 6 divided by ln of 3 over 5. And be careful when you type that into your calculator. Right here, ln of 6 divided by, and then I open a parentheses, because if you don't, then it's going to divide by ln of 3 and then divide that by 5. So ln of 6 divided by all of this. So put all of this in parentheses, ln of 3 over 5. So we get 8.155. And time in this one is days. So in 8.155 days, this bacteria would have increased by a factor of 6.